Okay, now this unit we're going to start by graphing what we call exponential equations. Okay, that exponential equation sounds like an exponent. Yeah, basically the x is going to be an exponent. So here I have y equals 1/2 times 3 to the x. There's two methods I'm going to cover. One of them I'm going to cover today and then the other one tomorrow. Okay, so two methods I'm going to cover. So the first method, let me make a table. I'm going to make a table here. I'm going to call it x. I'm going to leave some big space in between. And then over here, I'm going to call it y. I'm going to find out coordinates. I'm going to find points of my graph. So it gives me a good idea. Now, for the x value, I'm going to say when the base is more than 1. So I'm looking at the base here is 3 to the x. The base is 3. When the base is more than 1, my x values are going to go up. So I start with 0. And I'm going to choose 0, 1, 2, 3, and as far as I want, I'm going up. Now, if my base is less than 1, still positive, but less than 1, I'm talking about fractions, I'm going to go backwards. So 0, -1, -2, -3. All right, so again, when the base is positive more than 1, I go up. When it is a fraction, the x that I choose I'm going to choose negatives. And the reason why, because negative exponents undo fractions. All right, so I chose random values of x. Now I'm going to find the corresponding y value. All right, so the way I'm going to find that y value, I see my equation here, 1/2 times 3 to the x. So I'm just going to write that as 1/2 times 3 to the 0, right? Because I'm going to say x is equal to 0. All right, so that's basically 1/2 times 1, because anything to the 0 is always 1. 1/2 times 1, that is equal to 1/2. So that's my y value. If you notice, I have one coordinate, x equals 0, y equals 1/2. Okay, now let me find another point. Let me write the equation 1/2 times 3 to the 1. All right, because now I'm saying what if x equals 1? That is basically 1/2 times 3, right? Because 3 to the 1 isn't that 3? So 1/2 times 3, that is 3/2, which is roughly 1.5, right? In decimals is 1.5. So I can easily graph that one. Now what if x equals 2? Let me see this as 1/2 times 3 to the second. So I have 1/2 times 9. Isn't that 9/2? 9/2, I can see that as a decimal, right? Isn't that 4.5? Now, what if x equals 3? I'm going to write 1/2 times 3 to the third. That's 1/2 times 27, right? 3 to the third is 27. So that gives me 27 halves. Well, that's fine. That's 13.5 as a decimal. So I came out with points. My first point is 0, 1/2. That's it. So that is right here. Now, one thing, notice that each of my squares I'm counting by ones. In your homework, your multiple choices, your squares I'm going to be counting by 2s. Okay, so just be careful on that. My second point is x equals 1, y equals 1.5. All right, so that's not bad. That's about here. Then I have x equals 2, y equals 4.5. That's not bad. That's right here. When x equals 3, y equals 13.5. All right, I think we have a very good idea how my graph looks like. I'm going to connect my points. It looks a little curvy. Now, one thing on the left side, because I could have chosen negative values for x. On the left side, it does exist as well, but it is approaching 0. doesn't quite close, doesn't quite reach it. It's just approaching 0. That's it. Okay, let's take a look at question number 2. The base is 2, right? Because it's 2 to the x. The base, I said earlier, when the base is more than 1, the values of x that I'm going to choose are going to be positive. So let me make my table. My x values on the far left, my y values on the far right. There's some space in between. So I'm going to choose 0, 1, 2, and 3 for my x values. If my base was a fraction, I would have chosen negative values because negative exponents undo fractions. All right, so the equation is, as a matter of fact, let me even write it over here, 4 times 2 to the x. So if x equals 0, basically I have 4 times 2 to the 0. That is basically 4 times 1, because anything to the 0 is 1. All right, so 4 times 1 is 4. Now what if x equals 1? I have 4 times 2 to the 1, basically 4 times 2. So that's 8. What if x equals 2? I have 4 times 2 to the second. That's basically 4 times 4. All right, so 4 times 4, that's 16. Now what if x equals 3? I have 4 times 2 to the third. So basically 4 times 8. That's 32. Okay, so I have points. My first coordinate, you guys can see it. When x equals 0, y equals 4. So that gives me 0, 4. My second coordinate, you guys see it is 1, 8. Then I have 2, 16. The next one is 3 32s, but that one it's outside of my picture, so I'm not going to graph it. So I have a very good idea how this graph looks like. Little curvy, looks like this. Now, remember I said on the left side, it does exist. It's just approaching 0. It just never reaches it. So it looks like that. Now, what are we going to do when the fraction, when the base is a fraction? I said in that case, use negative values for x. So let's take a look. I have x in between. I'm on the far left. I have y on the far right. And in the center, I'm going to write 1/2 times 1/5 to the x, right? That's the equation. Now the x values, I'm always going to choose 0, but I'm also going to choose negative values. So -1, -2, -3. I'm going to choose, in this case, negative values. All right. Now if x equals 0, so I'm going to have 1/2 times 1/5 to the 0. That's basically 1/2 times 1. Because anything to the 0, so 1/5 to the 0, that's 1. Now 1/2 times 1, that's just 1/2. Now what if x equals -1? To begin with, I can write this as 1/2 times 1/5 to the -1, but that is basically 1/2 times 5 to the 1. Interesting. 1/5 to the -1 is basically 5 to the +1. The negative flips the fraction. So I'm just going to call it 1/2 times 5 to the 1, which is 1/2 times 5, better known as 5/2. So decimal, that's 2.5, so that's not a big deal. Now, what if x equals -2? That's going to give me 1/2 times 5 to the second. I already undid my fraction. Remember, negative exponents undo fractions. Right? I'm not gonna write 1/2 times 1/5 to the -2. I'm just gonna go 1/2 times 5 to the 2. I flip my fraction. The negative sign flips the fraction. All right, so 1/2 times 5 squared. Isn't that 1/2 times 25? So that is 25 halves. All right, so decimal, that's 12.5, so not a big deal. Now, what if x equals -3? I can see this as 1/2 times 5 to the third. Remember, my negative exponent flipped the fraction. So I'm looking at this as 1/2 times 125, which is 125 halves. That's a decimal, that's what? 62.5. Okay. So let's see, I can graph some points. The first one is 0, 1/2, right? X equals 0, y equals 1/2. So I can put that right there. The other one that I have is x equals -1, y equals 2.5, right? 5 halves is 2.5. So that gives me this right here. Then when x equals -2, y equals 12.5. And the third point, it doesn't fit. So I'm going to have that. Now, so it gives me, in this case, it looks like it's going down this way. And again, it does exist on the right side. It's just approaching 0. Interesting. When the base was more than 1, look at questions 1 and 2, my graph was going up. When my base is a fraction, it looks like my graph is going down. So just on the get-go, question number 4, if I had to graph this, I'm expecting something like this. I expect it going down because the base is 1/3, right? It's less than 1. Let's see if that's actually what we get. I'm going to create a table. There's an x value. On the far right, there's my y value. And in between, I have 2 times 1/3 to the x. Because the base, 1/3, is a fraction, I'm going to choose negative values. So 0, -1, -2, -3. When x equals 0, I have 2 times 1/3 to the 0, basically 2 times 1. So 1/3 to the 0 is 1. So that's 2, right? When x equals -1, I could begin with by writing 2 times 1/3 to the -1, or I could just start as 2 times 3 to the 1. Notice my negative fraction, my negative exponent, my negative exponent flipped the fraction. Now 2 times 3 to the 1, isn't that 2 times 3, better known as 6? So when x equals -2, I'm just going to call this 2 times 3 to the second. Remember that my negative exponent flipped my fraction. So I have this as 2 times 9, so that's 18. Now when x equals -3, I'm going to see this as 2 times 3 to the third. So it's basically 2 times 27, which is 54. Okay. So my first point is when x equals 0, y equals 2. So that's there. When x equals -1, y equals 6. So that's right there. The -2, 18. Now the third point, -3, 54, that one doesn't fit in my graph. So it looks like which is what I was expecting, right? I said I want a graph that going down. That's what I expected. So yeah. Again, notice that in my graphs, I was counting by ones. In your choices on your homework, each squared, I'm counting by 2s. So be careful on that.